This is lesson 56, multiplying polynomials. So I'm going to be teaching you today of a shortcut. So raise your hand if you like shortcuts. Okay, so we have shortcuts that we could use in math, and so today's a very quick lesson on how to use a shortcut. So the steps are the same as for the last 2 days, so we're not going to copy them. Okay, so let's look at all of these examples. Okay, so I don't want you to write these down, but this is what we've been learning from Ms. Good, right? So if we have two binomials being multiplied, I could create a box and multiply these out because this is like area, and then I have my final answer, right? And so these are three examples, but these three examples have a similarity. There's a pattern here, and I want you to turn to your neighbor really quick. Take about 30 seconds to a minute. I want you to observe the pattern by yourself, and then when you notice something between the original problem and the final answer, tell your neighbor. So focus on the original problem and the final answer. What do you notice? What do you observe? Okay? Go. Good. Did you notice what he said? If you have the threes, you have 3 times x, you got 2 3's, right? Right? Don't you notice you have 2 3x's, right? How do we get that? X times 3, right? On each of these. And there's 2 of them, so you can multiply them, or add them, you get 6x, right? Over here we have 2 7x's. Why? Because you have to multiply 7 times x twice, right? So 7x and 7x is 14x. You see that? Or right here we have negative 5x twice. What's negative 5x twice? Negative 10x, okay? So this shortcut works when we have the same binomial. You see how this is the same binomial being multiplied by itself. Okay? This only works when you have the same binomial being multiplied by itself. Turn to your neighbor and explain, when does this only work?
When it only works when the binomial is multiplied by itself. Binomial by itself.
So can I do this on any problem? No. Here's the shortcut. Okay, so when you see that, then I want you to also just don't do this middle step. I want you, when you see the shortcut, I don't need you to write all these boxes. I just want you to go straight to the answer, okay? Does that make sense? Okay, good. So, number 1 and 2, just watch right now. Number 1 is x plus 8 times x plus 8, okay? So, I notice it's the same binomial being multiplied by itself. Can I use a shortcut? Yes or no, class? Yes, okay, so now I'm going to just multiply. What's x times x? X squared. Then I'm going to say, what's 8 times 8? Positive 64. And then the middle term is just 8 times x is 8x. What's 2 times 8x? Positive 16x. I'm done. You see that? Yes, thank you. I deserve to be praised. No, I'm just playing. Here we go. Number 2. I'm joking. It was a joke. Like if you like the joke. Okay, like this video. Anyways, next one.
Teacher of the year.
That's right. Extra credit for Marky. Okay. Number 2. Can I use the pattern on number 2? Dab if you think I can use the pattern on number 2. Okay, good. X minus 6 times x minus 6. We got x times x is x squared, okay? Negative 6 times negative 6 is positive 36. X times negative 6 is negative 6x. I want to do that twice, so what's negative 6x times 2? Negative 12x. We're done. Oh, sorry about that. Yes, Marky.
Negative times a negative is a positive.
Right, negative 6 times negative 6 is positive 36.
Yeah, but negative 6x times
2, what's 2 times negative 6x? Negative 12x, right? Right, because look at the pattern from the last page. You see? Don't you have the same? Negative 5 and negative 5x twice, so it's negative 10x. Okay, good question. Okay, good. So I'd like you to turn your... Oh, question, yep. No, you cannot do this in trinomials. It only works in this case. This is the only way. If you have a binomial times itself. Okay? 1 Stella 2 is about number 1. 2 Stella 1 is about number 2. Ready, set, go. Okay, please write these down. As you're writing this down, someone asked me if we could still use the old box method that you just learned. Yes. Do you have to use the shortcut? No. Okay, don't use the shortcut. If you're not comfortable with it, then don't use it. But raise your hand if you want to save time. Okay, a lot of you do, so please use the shortcut. Write these both down. Go. Number 3. Here we go. So let's start this one off together. So let's write it down on our iPads. X plus 4 times x plus 4. Turn to your neighbor and tell them, can we use the shortcut on number 3? Yes or no?
Yes, sir, we can.
And tell them why you could use the shortcut. Okay, good. So let's start this one together. So let's multiply the first term. What's x times x?
X squared.
Good, x squared, okay. Then we got 4 times 4. Positive 16. So I'm going to press positive 16. Okay, I want you to finish this problem with your neighbor. I'll give you about 20 seconds. Go. Actually, probably less, 10 seconds. Okay, so the middle term is plus 8x. Good job. So if you made a mistake, please fix it, okay? Okay, number 4. Number 4. This one looks more difficult, right? We got the 2x plus 1. Can we use the shortcut on this one? Yes or no?
Yeah.
Yeah, we can. So I'll do the first one. What's 2x times 2x? 4x squared, okay?
I already got the answer.
Okay, finish up the problem for me. Go. Okay, so 2x times 2x is 4x squared, right? And then we do what's 1 squared or 1 times itself? Positive 1. That's at the end. Okay, look up here. All eyes up here. All eyes up here. Okay, 2x times 1 is 2x. Then we have to double it. So what's 2x times 2?
4.
4 what? 4x. Positive 4x. Because you have to double it. Because remember our pattern at the beginning here? Every time you double it, right? What's 7 times or x times 7? 7x. No, x times 7 is 7x times 2 because you have 2 of them. 14x. This is why. You always have 2 of them. Okay? So turn to your neighbor. I want you to tell him where you made a mistake on number 4 and how you're going to fix it. Ready? Set. Go. Second shortcut. I want you to look up here, please. Look up here. There's 3 problems up here. Just watch right now. This is the second kind of shortcut. With your neighbor, I want you to observe what's going on with the original problem and what's the final answer look like. And take a look at how I got there when you looked at the last couple of days, okay? Mikey, why don't you sit up here if you're lost? I think that helps you out because it does work. Okay, so turn to your neighbor. Ready, set, go. About this. Raise your hand. Someone take a guess or gander. Yep, what do you notice about this one?
You combine the like terms.
What like terms?
Positive 3x and negative 3x.
Turns into what?
Turns into 0.
Turns into 0, right? Do you notice on all of these, look at the top right of the box and bottom left, like positive 3x and negative 3x. Did you notice that these two cancel out on each one? Do you see that? Or how about these two, right here and here? Do you notice that that cancels out? Yeah? Do you notice that this one and this one cancels out? Okay. When do we use this pattern? You use this pattern when you have the first one. It's just like the second one, except that this one says x plus 3, and the second one is the same thing, x, but it says minus 3. Do you see that? So again, use the pattern by when you have the same binomial, except one has a positive second term and the other one has a negative second term. Okay?
So
yes?
It won't work if it's like that?
This is the only time it does work.
Oh.
What was does that answer your question?
It won't work if it's like, if it's x plus 3 and x minus 3, it won't work at all? The shortcut?
It does. This is x plus 3 and x minus 3. This is the shortcut.
Oh, I thought it has to be the same, like, has to be the same signs and everything.
Well, you need the parentheses here too.
It's a new. She's talking about the last shortcut. So this is the second shortcut, a different.
Yeah, this is a different shortcut. This is a new pattern. This is different than the first one.
Oh.
Do you see how these are both not the same? Do you all see that they're both not the same?
Yes.
Okay.
Yep.
So can we use the shortcut I just taught you today earlier?
Yes.
No, they're not the same. Can we use the same shortcut? You should get off your iPad so that you could focus here. Do we use the same shortcut as earlier?
No.
No, okay. So this is a new shortcut. When you have the same numbers, but you have a plus sign in one and a minus sign in the other in the middle, then we can use this shortcut. You following me? Okay, turn to your neighbor just to make sure. Explain the shortcut to them. Ready, set, go. I want to show you a couple of examples with the shortcut, okay? iPad's face down right now. iPad's face down. No one's using their iPads right now, okay? Okay, so on this example, we have x plus 8 times x minus 8. Do you notice how they look the same? But what's different? One's a plus sign in the middle, the other one has a negative sign. You all see that? So can I use the shortcut from earlier? No, I can't. So now I can use this new shortcut. So when I see this, all I got to do is square both of the first terms. So x times x is x squared. And then positive 8 times negative 8 is negative 64. That's it. I'm done. That's all you have to do.
You did that so quick.
I know. I did that so quick. Number 2. We have x minus 6 times x plus 6. Okay. X times x is, or I'm sorry, can I use the shortcut? Yeah, because the x's are both positive, but I have negative 6 and positive 6. You see, are my 6's different signs? Yes, so now I can use the shortcut. X times x is x squared. And then we have negative 6 times positive 6 is negative 36. Okay? That's how we apply the shortcut on this one. Yes?
Would you have to like solve the problem out as like negative x plus 6 and then x minus 6?
Yes, you would have to work it out because it wouldn't apply because the first term in each of them are different. Okay? Do you notice how this is a positive x and this is positive x? Okay. Marky's question was, what happens if the first one was positive and the second one was negative? Can I use the shortcut now? No, we can't use the shortcut. They both have to be positive. That's a good question. Okay?
What if they're both negative?
Then you can. Yep, you can still use the shortcut here. Okay? Good question. Right? They can use the shortcut on this one. All right. So, turn to your neighbor. Explain this particular shortcut. Let's have 1s till the 2s. What you need to have to apply the shortcut and how it's different than the one that I showed you earlier. And then 2s till the 1s, how I did both of these problems. Ready? Set. Go. Go. Number 3. Number 3. Okay? So let's write down number 3, please. X plus 4 times x minus 4. X plus 4 times x minus 4. Number 3. Okay. So, turn to your neighbor. Tell him, can we use the shortcut on this problem? Yes or no? And tell him why.
Because they're both the same.
Good. So they're both the same. We have x plus 4, so we have a positive first term, so positive x in both of them. Right? And the second one has a plus 4 and one has a minus 4. Okay? So we're going to apply the shortcut now. So x times x is?
X squared.
Good. What's positive 4 times negative 4? Finish up the problem and show me your work. 10 seconds. Go. Number 3, we got x squared minus 16. Excellent. Okay. What I'd like you to do is now number 4 all by yourself. All by yourself, number 4. Go. So we could apply it. We could apply the shortcut because 2x and 2x are both the same. They're both positive, or if they were both negative, it would have been fine too. So what's 2x times 2x? 4x squared. Okay. Then we know this is a positive 1, negative 1. What's positive 1 times? Look up here. A lot of you missed up, so eyes up here. Positive 1 times negative 1? Negative 1. Some of you put negative 4. I'm not sure what's going on there, right? Because you have positive 1 times negative 1 is negative 1, right? Okay. And that's it. That concludes the lesson.